Hello there, I'm Sajar Rabi. In my previous video, I was talking about simulating explosion with new Pyro solver in Houdini 18.5. In this video, I'm going to talk about some remained parts from my previous video. It is about simulating trails as well as Shockwave. Let's start with Shockwave first. For simulating Shockwave, you have a couple of methods. The main idea is generating velocity field, the outward velocity field from the source. So it's pushing your smoke outward and it's giving you some kind of the shock wave. For doing that, you can generate some custom velocity outside of your Pyro solver and inject it inside your dynamic network. You can use particle systems and add some outward spreading out motion to your particles and use the velocity of those particles inside your Pyro solver. Or even you can use a very simple object as a source of your smoke with very high velocity toward the ground. Because of that, your smoke is going down so fast, and because of the interaction between the ground collision object and the smoke, you would have some spreading out motion over your smoke. Of course, with this method, you need to play with some other microsolvers as well. For example, especially working with gas stick on collision with some negative number as its scale could be so helpful because of that your smoke is sliding easily over the ground and it's giving you very better result. In this tutorial, I want to show you another method which is so simple to set up. It's so handy to control the motion of your smoke. And of course, it's not the best method for simulating shock wave, but it could be so useful in most of the cases if you need to have some kind of the shock wave. Let's jump inside the Houdini and begin it. As usual, I am creating a geometry network and also I am going to use Pyro configure GPU explosion. And of course, we don't need to use a Pyro burst source because we don't want to simulate explosion. But just let me create some light source because currently the smoke is not so visible in the viewport. Maybe one more from the other side. Okay. Now inside the geometry network, I'm going to delete Pyro burst source. For Shockwave, I want to use very simple geometry. Maybe torus is good. And I'm decreasing the second radius. And if you want to have some animation on your source, for example, as a scale, you can do this by transform sub. At the first frame, it could be 0.1 or 15 keyframe, and in frame, for example, 10, it could be 1. So we have some motion like this. And before to convert your data to VDB, we have to add some attributes, mostly some attributes which are using inside the Pyro solver. For explosion, we need to have burn and temperature at least. But for the shockwave, as we don't have any fire inside the shockwave, we can just remove the burn and keep going with the density. So for adding these attributes to your source, you can use the Wrangles nodes, or of course you can do this by attribute create sub, but I prefer to use Pyro source node. It's so useful for adding some useful attributes, especially for Pyro solver, such as density, temperature, burn, fuel, and etc. In this case, I just want to add density. And here we go, we have density. If you want to have velocity as well, you can just create velocity data by trail sub, set the result type to compute velocity, and usually you're getting better result with backward with central difference. And now we have velocity and density. Now it's time to convert our attributes to VDB fields with volume rasterized attribute. But because we removed the pyroburst source, this expression here is not working. So you need to remove this expression and type the name of your attribute manually. In this case, we have density and V. Now we have two different VDB fields, density and velocity. Let's see what we have in the Pyro solver. Okay, that's good. Of course, it's not Shockwave, but it's working. In the sourcing, you can remove the burn because we don't need the burn, and also you can remove the temperature as well. In this method, I'm not going to use the temperature as well. We need just to have density and velocity. Okay, let me change the size of the container. As I said in my previous video, it is so simpler with using the simple box. So just connect the size to the max size and center to center. Okay, move it up. Extend it in all directions. Okay, that's good. Now what we need for simulating Shockwave is generating some extra velocity field and inject it to our Pyro solver. For doing that, I'm going to create a simple grid, maybe with more size and also more points, 200, 200. Now I want to create some velocity attributes, actually some outward velocity vectors from the center of the grid. For doing that, just using the point swap inside it, if you are going to connect position directly to the velocity, let me visualize the velocity field in the viewport. Oh, I already have some visualizer in here. Just let me delete it and make it again. V as a name and V for attributes. The type should be vector and with less length scale. As you see, we have some outward velocity vectors from the center. If you want to change this center, you can just subtract some position by the position of the points. For example, in the case your explosion source is not exactly at the center of the grid, you can just use this method to change this center here. Promote input 2, the type should be, of course, vector because we are talking about position. And now we can change this center very easily. But for now, just let's keep going with 0. As you see, because we are using the position directly, as long as we are going toward the edge of the grid, because the distance of the point is increasing from the center, the length of the velocity vector is increasing too. But for this project, I need to have same length for all of the velocity fields. As you guess, we can fix this problem with normalize node. It's going to normalize the length of all of velocity vectors to 1. That's good. Now we have velocity. But before to use this velocity for Pyro solver, we need to convert it to VDB as well. You can just use this volume rasterized attribute here, copy another version, and we want to convert V, and we have V as a VDB volume. Because we have two different velocity, one here and another one for our main source, it's better to change this name to something else just by name sub. I want to change the V to maybe V2 and merge it to our main graph. Now we have V and V2 and of course density. In the Pyro solver, I want to use this V2 inside my simulation. In the sourcing part, add another source. I want to read V2 and use this data as a well field. Same as here, but with different source name. For now, just let me turn off my main velocity, or maybe we don't need to use the first velocity. Let me see. Okay, it's not working. Okay, we need to change the field rank to vector because we have velocity, which is vector. And now it's working. As you see, we have something like Shockwave. But of course, we need to decrease dissipation. We need to decrease disturbance as well. Let's start with disturbance because we have some artifact and small noise in the smoke. In the shape, I want to use 5 as a disturbance. That's better. As you see, the smoke is disappearing so fast, so just decrease dissipation. Okay, and the source is repeating every 48 frames. That's because we need to change the source frame range and cycle length. As a cycle length, I'm going to use 240. And let's change the source frame range between 1 and 50. Okay, in the sourcing part, we need to use the V2 only on the very first frames of the simulation. So I'm going to set keyframe for scale. The first frame I want to use 1 and maybe frame 10 or 24, change it to 0. Okay, that's better. And we need to do same thing for density as well. The frame 1, just let's try using expression. If $FF or my current frame number is less than 4. So it's going to use density field only from frame 1 to 3. Good. Okay, now it's time to work on the overall shape of the shockwave and adding some extra details on it. For a sec, just let me turn off the disturbance. I want to see what is the overall shape of my shockwave. As you see, it's very fine circle shape. So to fix that issue, you can just add some curl noise to your outward velocity field. I'm going to create curl noise, connect position to the P, and using add function. Okay, what we have, yes, just let me increase length scale. As you see, we have some curl noise over my velocity vectors. What we have here is not circle anymore. Yes. Maybe We need to decrease amplitude to 0.5. Okay, that's better. Turn the disturbance back in the shape. Turn on disturbance. Okay. In the volume rasterized node, I would get better result by using less particle scale, and also change the filter to the box. It's just about tell this node how to sample data from the points to the VDB. And of course, we need to use some simple grid as a collision object too. As you see, we have some downward smoke. Simple grid. Make it larger. Because I want to convert this grid to the VDB, we need to have some thickness. So it's better to use volume extrude node. Now we have some depth or thickness. VDB from polygon. Okay. And don't forget to change this name to collision. That's how the Pyro solver is using this VDB as a collision object. Connected to the second input, now we have collision object, which is working very fine. And I want to use some turbulence as well to add some more large details on the smoke. But be careful about turbulence. In the turbulence tab, the influence field is set to temperature. But if you remember, we didn't use temperature. So I have to change it to density. I want to use the result of my turbulence on the density rather than temperature. Let me move it down a little bit, the collision object. Okay. Probably less dissipation. Okay, I think it's working fine. As you see, we have shockwave simulation with very simple method. I want to see what we have with more voxels. So decrease voxel size. Now we have more detail on the shockwave. If I want to have better motion of the shockwave, one thing I can do is playing with velocity data here. Currently, because of the curl noise, we have velocity vectors in both positive and negative y-axis, as you see. I want to do something to produce just velocity vectors toward the negative y-axis or downward. So at the beginning, my smoke should goes down instead of going up, but because of the collision object which we have here, it's going up after hitting to the collision object, and it's giving me better result. Let's do that. Inside the point swap, I need to extract x, y, and z axis from velocity field by vector to float node. And of course, we need to have float to vector as well. I don't want to change velocity in x and z axis, but just in the y axis. Okay, I'm going to use absolute node or ABS function. It's just converting all of the negative signs of the velocity y to positive. So currently we have velocity field just along the y-axis, in positive y-axis. I need to multiply this number to some negative number, I'm going to use multiply constant and multiply it by maybe negative 0.1. So I just have velocity field pointing downward, and let's see what we have here. Okay, as you see, we have a little better look of the shockwave. Probably we need to decrease dissipation here to some smaller number. And also our smoke is so dense in the look tab. I'm going to decrease density scale to maybe 10. And we need to inject density field from the source for longer frames. So in the sourcing tab, I'm going to change this number to maybe 10. We have more density at the beginning. And I'm going to change this keyframe for velocity. Maybe here. Okay, not too bad. Oh, we need to uh, extend our container size. Okay, I think that's good. Let me make a flipbook with more voxels, probably 0.03 or 0.5. Okay, I'm happy with the shockwave. If you want to change the look of the shockwave, you need just play with the parameters in the shape, disturbance, and turbulence, and of course, the curl noise inside the point valve here. Okay, let's jump to the next part. It's about simulating trail simulation for the explosion. Okay, simulating trail with Houdini 80.5 is so simple because we have some useful nodes for simulating trails. Let me show you. Again, I'm going to use Pyro configure explosion because I want to simulate my explosion and trails with my GPU. But if you want to do this with CPU, don't forget to turn off this minimal OpenCL solve option. I'm not going deeply through the explosion parts because I explained you everything in my previous video. For now, I just want to use this main default explosion. If you press tab and type trail, we have three new nodes: Pyro Trail, Trail Pass, and Trail Source. If you're going to use the first one, it's adding the other two ones for you. Now we have a trail path. Trail path is responsible for generating some paths and some data. If you press middlemost button, you would see that we have burst ID, start frame, trail ID, velocity, and time. You can control their shape very easily by these parameters like initial size, direction, shape offset, and for example spirit angle. And also in the trail generation you have some other parameters which are working on the shape. For example, you can change the gravity or mass. The trail source is generating some points based on this data which comes from the trail path. And you can control the shape of the points with trail shape part. For example, I want to have more points, maybe more length, and you can change radius as well. And also you can use some variation for any of these parameters with these two options. For example, as length, I want to add some variation and do same for the radius. We can also add some noise to the trails. As you see, we have more noise at the end of each trail. In the trail animation, we have control over the animation part. We have timing offset. We have timing speed. For example, I want to make it a little faster. Maybe 1.25 should be fine, or 1.2. We have trail component here. It's exactly same as trail bears component, which I explained you on my previous video. You have control over all of the attributes which you need for Pyro Solver. And for simulating trail, I want to have density and I need temperature as well. So I'm going to set it to the temperature. You have two important options here: scale over duration. If you turn it on, you would see that the amount of the temperature and density is decreasing over the animation. So at the end of the animation, it's going to be darker because we have less density and temperature. We have a scale along trailing option here. So we have more density and temperature at the tip of each trail and less density and temperature at the end of each trail. Usually using these two options is giving you better result for simulating trails. And we have output attributes part, same as output here in the PyroBurst source. Usually we are working with this part because of the velocity. For example, in the case you want to add some curl noise to your velocity. Of course, in this project, I am not going to use velocity data from the trail source, but just for PyroBurst source. In the next step, we need to convert these attributes to VDB field before injecting them to the Pyro solver. So you can use the same volume rasterize attributes here. Just make a copy and don't forget to remove this expression because it's connected to the Pyro burst source. I want to convert temperature and density attribute to VDB. But we have density and temperature on this side and we have same on the other side. So it would be better to change the name of the attributes for the trail source. It's giving you more control in the Pyro solver to do some special operation only on the temperature, for example, or density which comes from the trail source. For doing that, you need just go to the trail component and turn on this option here for both density and temperature. Now we have trail density, trail temperature, and don't forget to rename it in the volume rasterizer node. Trail density, trail temperature, and finally merge it to your main graph. We have temperature and we have trail temperature, and we have also trail density, but we don't have any density for bears node. In the Pyro solver, you need to go to the sourcing part and we need to inject the trail density inside the Pyro solver. Of course, I'm not going to use trail temperature inside my simulation. later on, I'm going to use trail temperature for adding some fire inside each trails. But for now, I just want to inject the trail density. So it would be better if you just use the split node and set the group to trail density. On this side, we have just trail density, and in the other side, we would have trail temperature, like so. So in the Pyro solver, you can remove the density part because, as I mentioned before, there is no density which comes from the Pyro burst source. So you can just remove it and add one extra field for just trail density. I'm going to set the name to trail density, and the type should be scalar because it's density, and I want to use this source as a density field. Okay, let's see what we have now. As you see now, we have some trails, but we need to change the frame range of the source. For now, we have trails from frame 1 to maybe 61. So in the Pyro solver, the start and end frame would be 1 and 61. And don't forget to change the cycle length based on your timeline. It should be 240. Working very well, but we definitely need to extend our container size. As I mentioned before, again, I'm going to use simple box because it's giving me some handles in the viewport to control its size. So just you need to connect the size to the max size, space relative references, and same for center. Let's keep going with 20, 20, 20, and 10. Set this size based on your trail points. We need to extend it at this side and this side. Okay, something like that. Because it's in the back of the explosion, I don't need to have a large container size on this side. Just let's keep going in the front. Okay. Simulate it again. Working very good. Maybe we need to change this position of the spotlights. Something like that. Okay, in the explosion, I want to decrease dissipation in the solving shape. I'm going to use 0.05, and maybe we need to have less disturbance. Would be good if we have some turbulence. Yes, and if you want to have some more smoke, especially at the end of the simulation here, you can use just one more source here to producing some density and temperature, because for now we have pyro burst source just only very first frames of the simulation. Just let me do a simple, just let me increase the number of the voxels in the setup. I'm going to use 0.7 to have more details. I think that should be fine for now, but there is one problem. We don't have any fire at the end of each, we don't have any fire at the tip of each trail. So let's do that. Before keep going, let me create bake, a pyro bake volume, because you need to do this inside the pyro bake volume. Maybe more density and make it darker. We need to turn on scatter part for the explosion and increase intensity scale. Just don't forget about that simple tips which I told you on my previous video. It was about using the temperature option here. By turning this option on, the Pyro solver is going to generate the temperature field during the simulation time, and it's giving you better result when working with the scatter part in the Pyro bake volume. So I'm going to use this option and simulate it again. Maybe frame 24 or 25. Okay, that's better. Now it's time to work on the fire only for the trails. For doing that, you need to play with the secondary fire. The secondary fire is going to use trail temperature as a source of the secondary fire. So we need to use the trail temperature on this side. I'm going to merge it to the output of the Pyro solver. Now we have a trail temperature. And now if you turn on this option here, you would have some fire at the tip of each trail. Okay, one other thing which I can do to make it better is adding some small details to the fire of each trail. For doing that, you need to play with the trail temperature and the trail source. I'm going to add some noise for both temperature and density. And check the result again. Now we have some small details on the fire area. And I think it would be better if we have, for example, some fire on some of the trails, and maybe some of them we don't need to have fire. It would be better if we could have some larger scale of the noise to control the trails. For example, for now, all of them has exactly same amount of the fire. For doing that, you need to use larger scale of the temperature. Just temporarily, let me turn off the density source. I want to see just the temperature in the viewport. I'm going to increase the size to maybe 5, maybe more amplitude. Okay, that's good. For example, we have lots of temperature on this trail, and we have less temperature on this group of the trails. And check the result again. Okay, it's working. We have some fire on this group and no fire on this group, but we are with this method we are losing that small details which we had on the trails, because I used a large scale of the noise. I don't have any small scale noise. For doing that, I have to use another pass of the noise on top of my first noise. So for doing that, you can use the new attribute adjust float node. I want to work on the trail temperature, visualize it on the viewport, and use some noise. and just don't forget to multiply it with the result of our previous noise here. So don't forget to set this option to multiply. Let's visualize it in the viewport. Make it smaller. That should be fine. Okay. And turn density back. Check it again. Okay, and we have some smaller noise and a bigger noise for all of the trails. Okay, that's good. And one more thing which I can do is adding some volume scattering, same as what we have for the main explosion for the trails as well. Currently, the volume scattering just working on the main explosion. That's because it's using the main temperature as a source of scatter. It's not using the trail temperature. For doing that, you need to combine the trail temperature field on this side with your main temperature. Before doing that, let me convert all of them to the VDB because VDB is more efficient. Just VDB convert and convert all of the input fields to the VDB. And trail VDB, trail temperature is VDB already. So we have all of them ready. Just I want to combine both temperature together. VDB combine and combine main temperature with my second trail temperature and set the operation to add. Let's check it again. It's not so clear. Maybe that's because we need to scale up trail temperature on this side. I'm going to use just volume wrangle and trail temperature multiply it by, let's try some huge number, maybe 1000. Oops, I've used wrong name. Okay, now it's working. We have some volume scattering on the trail. It's giving you better look at the render time and maybe more. It's more clear on this trail. Yeah, much better. Let me do a simple flipbook to see what we have for now. Of course, with more voxels. So decrease voxel size and flipbook. Okay, here is the flipbook. Of course, you need to play more with the disturbance and turbulence and overall shape of your explosion. But in terms of the trail simulation, it's working very well. And here is another example. I just render a few frames. For the trail simulation, I've used exactly the same techniques as I told you in this tutorial. And for the explosion, I use my setup from my previous video with the same shading, and I just simulated 3 different explosions because I needed to have a very large scale explosion with GPU. And the last note is about having correct volume scattering while you have multiple pyro simulation. For example, in this explosion, I have some white smoke inside the main explosion. As you see, we have some volume scattering which comes from the main explosion and goes through the white smoke. Or at this frame, On that case, you need just to inject temperature field of the main explosion to the white smoke. In the case of the white smoke, you don't need to use temperature at all. And here we have density of the white smoke, and here we have temperature of the main explosion. Merge them together, we have density and temperature. In the pyrobake volume, by turning on this option, you would have some volume scattering which comes from the explosion inside the white smoke. And if you wanted to spread more this volume scattering, here you can convert your temperature to VDB if it's not, and use VDB active sub to expand active voxels of the temperature, and finally using VDB smooth sub. By using more iteration, we would have more spreading. And let's see what we have. Okay, we have some correct volume scattering inside white smoke as well. And in this simple setup for white smoke, again, I've used Pyro configure GPU explosion, but in white smoke, you don't have any fire. So in the Pyro burst source, in the burst component, we need to have density and temperature. Okay, guys, I think that's pretty much it. Thanks for watching this tutorial. I hope you enjoyed it. And in the next tutorial, I'm going to talk about fire and smoke simulation, as well as some simple tips about shading. So see you in the next tutorial.